Today, I want to just take a few minutes to talk a little bit about my experiences with designing pivots in outdoor environments. There's a lot of different challenges, I would say, that come up with the design processes that you guys have. And there's a lot of products and offerings that igus can help with and offer to help you guys get over those challenges and to really create a good, long-standing application in these type of environments. As Nicole said, my name is Nick Van Tall. I am the North American Industry Manager responsible for agricultural and construction equipment. I am based out of Kansas City, and I've been with igus for the past 12 years. I have lots of experience in this arena. I spent the first 8 years of my career dealing with the customers in Kansas, so lots of ag, lots of construction type of customers in there. And I've taken that experience over into this industry management role, and I hope that all this information I'm about to share with you helps you guys out, sparks some interest, and then we can go a little bit deeper on a one-on-one basis with everybody. So with that being said, let's get started. And what we're going to talk about today is some of the common design challenges that I have seen in the industry. There's a lot of them that you guys deal with, but the most common ones that I see are going to be maintenance challenges, either trying to get rid of grease or make it easier for somebody to keep a joint maintained. Dirt is obviously a constant issue when it comes to outdoor applications. Rust, corrosion, any of those type of parameters and things are challenging for you guys to make sure that we take out of the system and we really make the long-lasting life that you guys are looking for on the machines. So what I've done over the past years is I've taken a lot of my experience and different customers, and we've really put this into a design, or not a design, but a concept that I think really shows you guys how we can help you guys in all these different arenas. So I put together a tech talk a few years ago called Designing a True Maintenance-Free Pivot. And basically what this tech talk talks about is how to really successfully design that outdoor pivot and the different aspects of it that really need to be taken into account when it comes to designing the application. So I'm stealing this from one of my colleagues, but this is a really great visual for everybody. So when you design a pivot in outdoor, it's kind of like a three-legged stool. You really have to take care of these three different types of aspects in order to really make it run and truly get it to last how you guys are wanting it to last. When you take one of them away or you don't put as much time and effort into one of them, the stool falls over and then you don't have the best running application that you're looking for. So in these applications, you got to look at the housing, you got to look at the shaft, and you have to look at the bushing. Without one of these parameters being really taken care of and really looked at closely or having some sort of a design consideration around it, you can really run the risk of having a pivot that fails prematurely, doesn't quite give you the life that you're looking for, and doesn't quite satisfy your customers' needs. So I'm going to go through each one of these, talk about the things that we offer to address each one of these parameters, and then we can go a little bit deeper into talks if need be. So the first one, obviously a good dry running maintenance-free bushing is what you need in order to really be successful in outdoor. As we've seen over the last 5, 10, almost 15 years, one of the biggest questions or the biggest sort of desires in a design is how to remove as much maintenance as possible. And maintenance is usually grease, right? So the liquid lubrication that you would need in order to get a traditional metal bearing to run in an application. Well, iGlide, all of our materials are dry running. They are all capable of being used without external lubrication, and they all will stand up to the environment that you're looking for with the dirt, the UVs, the chemicals, the high loading, the edge loading, all of the different things that come into outdoor applications. All of our materials are built to last in those type of applications. So all of our materials, for those of you that aren't aware, are made up of 3 components. There's a base polymer, there's a fiber, and then there's a solid lubricant that's built into all of them. The base polymer can be a number of different base plastics, PTFE, PEEK, nylon, whatever it happens to be. The fibers and filaments range from different types depending on what we want that bearing to perform and how we expect it to take loading. And then of course the solid lubricants are what's built into that system. So as it's running and as it's wearing against the shaft, it's actually depositing material. It's actually releasing some of that solid lubricant to make it a good running surface between the bushing and the shaft. The great thing about it with igus is that we have probably 26 to 30 different materials that we call standards that are readily available off the shelf with sizes already created, but all of them have their unique use and unique need in the application. So we have a lot of materials that will handle very high chemical resistance, but they're not the greatest when it comes to, dirt or any sort of contaminant in the system. And so those would be ones that we would shy away from. but igus has the expertise to know, okay, these specific materials can really help you guys in the outdoor application to really help you guys get the life you're looking for. Some of the common materials that we use quite a bit in outdoor applications would be these four. The AgGlide G300 is really kind of our all-arounder, great material that we work for, and it goes probably 80% of the applications out there. We have by far the most stock sizes available in G300, both in imperial and metric sizes, and it has a really good resistance to loading and the application. Impervious to dirt, it's a hard enough material that it won't allow material to embed in it, so it can actually just push the dirt out of the way and get back to running in a smooth area. And it's a very easy material for us to mold very large parts. We have some applications where we get into 5-inch, 6-inch diameter parts. And with the G300, it's one of our more forgiving materials when it comes to molding those large parts, and actually gives us the capacity loading that we need in those very large applications. The AgGlide Q2 has been around now for maybe 8-9 years. This is what we would call our high load capacity type of bearing. As you can see, it takes a pretty high load, static load in the applications, and it's also available in a lot of different variant sizes. We've done a lot of work over the last couple of years with those two materials specifically to tool up and create a lot of thicker walled parts to help replace some of the thicker walled metal parts that have been used for decades in the application. So if there's something that you guys have looked at us in the past and we didn't quite have the wall thickness that you need for the application, definitely come back to us now. We have a lot more of those available for you guys, and we can definitely offer some direct drop-in replacements in those applications. iGlide P, I want to touch on that one next. This one's a really good cost-effective all-arounder. If there's an application where the loads really aren't that high, there's a lot of moisture out there, and you just need something that's going to be a cost-effective, really great material, then iGlide P is a really good one for us to use. We have a lot of examples of it being in really cold environments, extremely wet environments, dirty, and all those type of things, and it holds up very, very well. It's just a great material for us. And then Q2E, this is a brand new material for us. We just launched it late last year. So what this is a two-piece construction. We have a very hard outer shell, and then the inner liner is actually the bearing surface. So the idea of this is that we can take extremely high loads in applications, and we can also do edge loading much better than you would see out of other typical two-part bushings and out of metal bushings. That inner layer is the Q2 material that I mentioned a second ago, and it actually will give you the great wear resistance that you need in the application while allowing that outer shell to sort of take the high load capacity, and it keeps the bushing and the bearing, everything in place much better when you get in those extreme loading. As you can see by the picture, the wear surface goes all the way to the edge, and because that wear surface is the Q2 material, it's very good with edge loading. It has a good elasticity that as long as you, even though the loading may be offset onto the edge, it will come back into its form without deforming or what they call cold flow or oozing out of the application, I should say. So these are some of the common ones. Like I mentioned before, there are 20 to 30 different materials that we have available in igus. These are kind of the ones that we use the most, but certainly if the application calls for it, we have the experience and the knowledge of all of our other materials to start looking at other places. Number 2 on the three-legged stool would be the shafting. So this is probably the biggest proponent of failures in the field that I have seen in my career. So one of the problems that we have with shafting is that it tends to be one of the, not the most overlooked, but it tends to be one of the overlooked areas of it. Everyone is focused on the bushing, rightfully so, because that's where you want it to be. But in order for you to go to a dry running, truly maintenance-free pivot, you have to find some way to have a shafting in there that's going to survive and last in the environment. In the past, when you had a greased application, the grease did a couple different things. One, it kept the bushing running smoothly, the metal bushing, and kept that running, but it also protected the pin and the housing, which we'll talk about in a minute, from corrosion. When you remove that grease and just simply put in a maintenance-free bushing, you actually are now introducing other elements in the application that you had inadvertently not had to deal with in the past. So what we did is we came up with this product line called GKF shafting. This is new to our product line for a couple of years now. We've had some really good success with customers. It's a hardened carbon alloy pin that's completely corrosion resistant on every facet of the pin, and it really helps the bushing run and provide that long life that you're looking for. One of the things that I had seen with some customers is that when we go to a maintenance-free pivot and we remove that grease, the corrosion really starts to set in and really start to have a problem. And it really starts to not only break down the bushing quickly, but the pin will start to wear out. And then you could potentially have a really bad failure where you start to wear into the housing and start to damage that, which can be very expensive for the end user to go back through and fix those. Well, what this does is it helps put the wear and the ownership back on the bushing solely. So the idea was to be for this pin to last for the lifetime of the machine. Let the bushing be the thing that wears out because that's what it's for. It's a wear item. And then leave the pin, the more expensive of things, alone, as long as there's no catastrophic damage done to the overall machine. This is a version of a process that's been around for a while. It's a version of nitrating. The GKF process is actually something that we have proprietary to igus. There's a lot of steps and a lot of things that we have figured out on our end to make this run really well against our bushings. And it actually has much better corrosion resistance than you would get out of zinc or chrome. You know, the one challenge with zinc and chrome is that they are coatings. They are removed almost immediately once you start running a bushing on them. And then you just have bare alloy sitting there getting exposed to the environment and the elements. Like I mentioned, we can do a complete protected part. So as you see here, we have a part that has a flag, a retention flag welded onto it. And we also have a full assembly, which is a roller type assembly where we do have our bushings inside of that. So there's lots of different ways that we can offer this process and this part to really make the application a success for you guys. So this was an in-house test that we did for a customer on one of his applications. We just wanted to kind of show you some wear results with our bushings on GKF. As you can see, it's a decent loading. It's not very high loading. It's kind of an average loading for the industry. But what we did is we actually oscillated it 20 degrees and 50 degrees, and we traded that off depending on how the customer wanted us to run it. And as you can see, the bushings running on the GKF shafting, which is on the right, is actually much lower on the wear rate than you're seeing for the bushings on the left, which are on just standard 1045 cold rolled steel. The big advantage here is that our surface finish is much better. The hardness of our pin is much higher, and that actually allows our bushings to run for much longer. You can see on the left-hand side, the Q2 bushing is actually starting to fail when it was running on just the simple 1045. And then you can also see some of the damage that's being caused to the pin. So that pin on the left actually has a little bit of wear into the pin. Our materials, the Q2 and the G300, they're hard enough that if the pin is not hard, you can actually start to wear into it and cause damage. And so we try to avoid that by offering the GKF, which gives you that really hard running surface that you need and allows the bushings to really run for the life that we're expecting. And the third aspect, and this is absolutely the most overlooked aspect of applications, would be how to protect the housing from dirt and also corrosion. So as you can see by these pictures, both of them can cause significant issues in the application. From a corrosion standpoint, we really don't think about the housing much on the internal sides because we just think, okay, let's bore it out, we'll put a bushing in it, and then we paint the outside of it to match the colors of the machine. And that paint does protect the outside of the machine, sort of, but the inside of the housing is actually what's causing a lot of problems in the application. So as that internal housing gets exposed to the elements, rain, moisture, dirt, everything else, you actually start to get a lot of corrosion inside of there. And you'll get a corrosion in two different areas. So you'll get a corrosion in the very middle of the housing where there is no bushing. And the problem with that is all of those metal flakes will start to flake away and get between the bushing and the pin and start to really cause problems and wearing out the bushing prematurely. The other part of it is you'll get corrosion behind the bushing where it's actually pressed into. And when that happens, the housing will start to actually grow because of the corrosion, which then squeezes on the bushing and removes any clearance that you have in the application, which increases friction, which increases wear and just causes everything to fail. The other challenge is dirt contamination. Now, our bushings are able to run in dirt. The dirt itself is not really an inhibiting factor for us. The challenge is when it gets so caked up into an application where it has nowhere to go, that really becomes a problem. So as you can see the picture on the top there, this is a picture of a housing that has a lot of dirt in it. There are bushings in there. Actually, it was Q2E bushings inside of there, but you can't see it because of how much dirt was in there. So there are a couple of things that we have had customers test and try, and we've tested ourselves to really show and give you guys a good protection for housings. There are a couple of different ways to protect the housing. One would be a simple sort of corrosion protection in the housing. Both of these products that you see here, These are not our products. We do not sell these, but these are products that we've had customers use with success in the past. So both of them are sort of a wax-based type of spray, and you can get them both in a dippable sort of paint type of texture. So the aerosols I know can be hazardous sometimes in manufacturing plants. But the idea behind this is that you would take this applicators of these products, you would wipe it into the housing before you press the bushing in, and then you press the bushing in. And these products dry to almost a complete dry feel, and they might have a slight little bit of a feel to them, but it's not enough to really cause problems. And what these do is they protect the inside of the housing from corrosion, to keep that from corrosion from building and having issues in the application. Now, the other way to protect the housing is seals. Seals are nothing new. Everybody uses them in different applications and how they're used. Some are better than others in applications, and some will actually give you better life and be much less expensive than you would expect out of other seals. So, common one that I see a lot are rubber lip seals. As you can see on this application, there are rubber lip seals installed on this housing, but there is still a ton of dirt inside of the application. There was a seal on the backside as well. So what happened in this is that this particular application got a lot of edge loading and a lot of offset loading. And so as it's getting that offset loading, the rubber lip seals will deform and cause a little channel for all the dirt and debris that's in the application and in the air to work its way inside of the application. And you can see it got quite a bit inside of there. One of the drawbacks of rubber seals is that they're really hard unless it's going to be just a straight shot, no movement, no edge loading. It's really hard to keep them solid against the shaft. Also, they create a lot more friction in the application than you expect just from the bushing alone, because you have to have that seal very, very tight up against the shaft. One sealing option that we have seen and we've had some good success with are felt seals. It's a very old technology. Obviously, felt's been around for many, many years, but it's something that really works well in these type of environments because it acts like a screen and really helps to filter out all of the dust and the dirt and everything that could be in an application. We've had a couple of different instances where we tried to do testing on flanges and thrust washers, as you see there. And the picture on the bottom with the black bushing and the yellow zinc pin was actually a test that we did in our lab using a bag full of sand. We basically buried it in sand and had it run. And as you can see, the felt being on the outside of that flange protected the entire flange and did not allow any dirt or sand to penetrate down into the bushing. And you can see that the shaft looks in pretty good shape after only 20 or 30,000 cycles. It wasn't a very long test, but the idea behind it was to sort of just prove that, okay, felt can be used. There are lots of ways to use it. There are better ways than not to design it in an application. It's extremely inexpensive, and it's something that we can help you guys sort of better understand and help you guys to design it into the application so that it will really last and protect the inside of that part as best as possible. So I know this was really quick and there was a lot of things that I brought up in this, but this was really kind of intended just to be a quick overview of some of the things that we have seen in the industry and let you know that we do have products and solutions available for you. There are lots of different ways that we can go much deeper into these concepts, and I can really get into some more nitty-gritty numbers with everybody. If you have any questions or there's additional information that you would like, or you just want to sort of get some more information on everything that we've been talking about, there are several different ways. And because of the COVID situation, we have actually set up a couple of different trade show booths that we can do virtual tours on. So this picture here is our trade show booth in the North American office. We can do a guided tour with individuals who are in the office right now helping, that we can do a quick Teams meeting just like we're doing now. They can show you different things in the booth, talk to you a little bit more in detail about it while we guide you through the application. We also have a whole booth set up at our Germany facility, which I'll show you here in just a second. It was in response to the fact that one of our biggest trade shows that we do every year, HMI in Germany, was canceled due to COVID. So instead of just not doing anything, they actually took the entire booth and they set it up inside of our factory in Cologne, and they made it a virtual experience where you can actually go through, you can do self-guided tours. We can have our counterparts that are in Germany walk us through the booth with you to show you different applications, to give you different ideas of the news and all of the new products that we have coming out this year. And it's free. There's a web address you can go to and you can take a look at those. We can also do virtual project reviews with your local igus contact. As I mentioned before, we have over 120 of them here in North America. So we can get on a Teams meeting with you guys. We can share screens. We can talk about applications, and we can go very, very deep into any questions or information that you're needing. We do virtual lunch and learns right now, kind of very similar to what we would normally do for lunch and learn. We can send guys samples to their homes if that's where they happen to be. We can send snack boxes, different product samples, things like that. And then we can do what we call a virtual lunch and learn, where we can go through the different products that we offer, talk more in depth, really have a long conversation with more people in the company to really get everybody's feedback in there. And then, of course, when we do future webinars, we can also email you so that you have that information as well. This is a screenshot of our virtual tour in igus Cologne. So as you can see, there's other industry highlights in here, all the different materials and products set up in here. You can click on the different blue buttons. It can take you different places and have information, lots of videos, lots of interactive things with this.